Digital applications nowadays are transitioning from monolithic to cloud-native applications. Orchestration, automation, programmability are the key pillars in the roadmap for such applications. We at HSC have developed Distributed Virtualization Test Framework. This is an OpenStack-based test framework which can help you design, test, and deploy your orchestration solutions for cloud-native applications. It can help you test such applications with respect to functionality, load, resource benchmarking, scalability, etc. It provides an easy-to-integrate SDK for automating the life cycle of these applications, supports containerized environments and declarative provisionings which can be reused in the production environment. It supports standard specification languages like Tosca and Heat and reduces the development production parity. Language bindings of the SDK helps in easy integration with the applications. Service registry, scaling, service function chaining, logging APIs augment this microservices-based architecture of these applications. Next, we plan to integrate this with the SDN controller to control the networking infrastructure programmatically, gain the real-time visibility, and integrate business policies into the infrastructure. We start with a simple OpenStack-based deployment where we could deploy some applications in the VMs and share the data among them to get some diagnostic or performance information. We termed it as Generic Test Framework GTF. But with strong emphasis of applications migrating to microservices architecture, we decided to augment this with the capabilities to provision such applications as network services of NFA. Supporting service function chaining, provisioning the resources for each VNF of a network service, allowing scaling of VNFs, augmenting our SDK with supporting infrastructure services like data sharing or logging. This is when we decided to rename the GTF to a more apt term, DVTF, Distributed Virtualization Test Framework. As a demo use case for the solution, we took sample applications APSIM and SON, which were considered individual VNFs in our case. They are just simple emulators sharing some information on TCP connections. To test the complete service function chaining concept, we introduced a dummy firewall between these two test VNFs so that we test the end-to-end service function chaining. Before deploying a network service, our solution expects the basic infrastructure to be up. This is done as part of the project creation within the OpenStack deployment. We create a GTF infra controller, which is the interface between the GUI and the underlying OpenStack deployment. It handles all the infra services and communicates with the OpenStack services when needed. For the networking, the management network handles the communications with the VNF, and the platform network is what is used for all the infra services as well as for the inter-VM communication for the data traffic. Before the demo, a quick note on the flow of the demo. So it starts with the project creation in the DVTF platform, followed by the designing of an end-to-end network service, doing the resource provisioning and software deployments for it. The desired service function chain is created from the GUI. This is followed by the SDK capabilities for centralized logging, QoS configuration to emulate bandwidth or latency constraints in the links between the VNFs, data sharing between VNFs using publish-subscribe models. The demo ends with the scaling capabilities supported in the DVTF. So you can have application-defined scaling, or you can have it on the basis of telemetry stats that OpenStack supports. We are open to any questions for the demo. Over to the demo now.